Let's discuss the question number 50 and 51. It's a common data question from test series 1 and the topic is solid mechanics, or in fact the machine design, you can say machine design, because this theory of it depends because they are interrelated. So I will go with machine design. Okay, so what is given is a shaft is given, okay, and a pure torque is applied, so there are no other forces, you have only twisting, so that will lead to pure shear. And if you take an element, okay, so you will have the shear stresses which are distributed like this, okay, and the value is already given, so you need not find out the shear stress based on torque, directly the value is given. And the yield point, let me denote it by sigma y, that is given 435 Newton mm square. Okay, so now what is asked is, using the maximum shear stress theory, the factor of safety is asked. So let's do, okay, so what does maximum shear stress theory says? It says the material fails when my maximum shear stress is equal to my shear stress in a yielding case. Okay, so this is my tau y, the shear stress. That means if I put the same, if I have a complex state of stress, say any here it's simple, but if I have a complex state of stress, and that I'm basically equating it, this same material, if I conduct only a uniaxial test, okay, so always a complex state of stress and then a yield strength, because properties and all you will measure through a uniaxial yield test, right? Uniaxial tension test. Yield I'm removing. So always, all these 5 theories of failures, you will always compare a complex state of stress, some parameter in complex state of stress, with the equivalent parameter in the uniaxial test. So that is the logic. So the maximum shear stress theory, which is the third theory, what it says is the maximum shear stress in a complex case is equal to the shear stress in the uniaxial case, but we provide always the factor of safety. The factor of safety is written like this. So this is your statement. Now tau max, anyhow I have the state of stress is only pure shear, so my tau max everywhere will be 70. Okay, and tau y, okay, is related to my sigma y by this. The tau y is basically sigma y by 2, and yeah, because how do we get, because if you find out, in this case, see, the only stress is sigma y here, okay, and there are no stresses here, so the maximum principal stress in this case is sigma y, and the tau max is always the difference between the max and the minimum, and the max is sigma y, sigma 3, there are no other stresses, so it is sigma y by 2. Okay, the yield, the shear yield in a uniaxial test is basically related to the yield stress by this factor, by the factor of 2. So now FOS in this case will be sigma y by 2 into 70. Sigma y given is 435, so 435 by 140, which comes to be 3.10. Answer is B. Okay, now let's discuss the question number 51, where they have asked us to use the distortion energy theory. So distortion energy theory, or the von Mises theory, where you calculate in a complex state of stress, you calculate the von Mises function and then equate it to the equivalent thing in yield strength. So it comes out to be like this. Let me write down for a 2D case the von Mises function for a 2D case. It is something like this: root over sigma 1 square plus sigma 2 square minus the sigma 1 sigma 2 and that is equal to sigma y by f of s. So this is my von Mises or the distortion energy theory function. Now remember that sigma 1 and the sigma 2 are my principal stresses in the 2D case. See, this is a 2D case, so I can just find out this principal stress and the maximum stress. Either you can find out from the mode circle, or you can use sigma 1 as the general formula for a 2D. Like if I have a 2D state of stress, something like this, sigma x and then tau. So in our case, sigma x is 0, sigma y is 0, only tau is there. So so the general formula from the mode circle, it comes out to be this. For sigma 1 comma 2, the general formula is this. So sigma x, sigma y individually are 0, so what I am left with is tau square, which is plus or minus tau. So that means sigma 1 is tau, sigma 2 is minus tau. So if I use this function, I'll get tau square plus tau square minus tau sigma y by f of s. Okay, so sigma y in a yield strength is sigma y. So this I'll get root 3 tau is equal to sigma y by f of s, and f of s is basically sigma y by root 3 tau. Sigma y given is 435 by root 3 and the tau value is 70. So the f of s in this distortion energy case comes out to be, let's look at the let's use a calculator to calculate, and the f of s value comes out to be 3 point, let me just calculate it. Yeah, so 435 by root 3 into 70, it comes out to be 3.58 roughly. So the answer is D, looking at the option. Thank you.